go out that's ready to ramp up and down, or, you know, is gonna be the belt to fill the press feed pumps down in the basement, but when you're at that point,
Yeah. Yep.
but they're all the same.
Yeah, I mean, from an operator's perspective, there are a couple of internal differences, but that's more for like the electricians and stuff, and maybe at some point kind of cut the operators loose. And
Eric should be up in a few, he's just downstairs.
oh, okay. All right.
I'll let him know you're here. You know, he's had a couple of things to take care of.
I haven't seen Eric in a while.
Is he? You want to wait a couple minutes?
I don't know if Ozzy was away, I don't know if he's gonna back up on.
Just go.
All right. Yeah, it's about 8:30.
No, you don't.
So,
That's a popular name.
all right.
We're gonna get a couple.
I don't. Oh, you have to excuse me, I'm fighting a serious infection with one of my feet. Killing it. I'm trying to do this without painkillers, but if worst comes to worst, we may have to take some drugs here to get through the day. Hope you're not getting that.
No.
Oh,
You
man.
said you need some good drugs?
No, I have some good drugs, I'm just trying not to take them. Oh, because then this gutter and those Bruce class is gonna go. Probably go into the gutter real quick, because I'm about this far away from the gutter under normal circumstances. Anyway, my name is Pete Sullivan, drive specialist from Northeast Electrical Distributors. We're the authorized Allen Bradley distributor in this territory. Rockwell Automation, Allen Bradley, same company. Technically, they go by the term Rockwell Automation today, but it's still Allen Bradley. It's been AV forever and will continue to be AV. Allen Bradley Rockwell is a little different than other vendors in that there is one distributor per territory. Okay, so every distributor is assigned a piece of dirt. So we are the only authorized Allen Bradley distributor in this territory. There are others that may say they are, but they're not. They're not authorized and will not get factory support if they are making sales in this territory. In this area, there's only one other that might encroach on our dirt, and that would be Horizon Solutions, but I doubt that they would. Anyway, if you have any issues, spare parts, service requests, anything like that, we would be your primary focus and point of contact. This is phase 3 of this project. So phase 1 and 2, we're basically using the same drives that we used on phase 3. These are a little different. They're manufactured by a third-party company, Elm Electric out in Springfield. They actually fabricated these. They're an authorized Allen Bradley system integrator, which means they have gone through all the rigors that are required to build Allen Bradley drives. So while not being an Allen Bradley factory, they have passed muster with Allen Bradley and have built these drives for this project. Reason being, pure price. Drives on this and the other projects are all custom designed for this project to meet the specifications done by CDM. But they're all basically the same core drive. The drives that are used here are PowerFlex 70 and 700. If they're under 50 horsepower, there'll be a PowerFlex 70. If they're over 50 horsepower, there'll be a PowerFlex 700. Reason being, that's where the drives go. They don't, the 70 does not go over 50 horse. The 700 goes all the way up, but it's more cost effective to use the 70. Basically the same specifications between the two products. Horsepower is the biggest single difference. We're just going to go over quickly some of the installation considerations, things to be aware of. Again, you guys aren't installing them. They're being installed by Griffin Electric, I believe.
Yep.
Okay, so you really shouldn't have to be concerned with this. However, I think it's important that you understand these installation considerations, because I think they're very important. And if you do come across, let's say, some problems in the field, it's really one of the first places you start to look. Because if you have problems with a drive, very rarely the drive. It's usually the way they're installed or something in the field is creating a problem. High failures. You see, a drive fails twice in a year. Well, that's not normal, okay? There's thousands and thousands and thousands of these drives out there. They don't have, that's just well outside the failure rate. So when we see things like that, we do get involved. Make sure you get us involved. Don't wait, don't put 5 drives in before you say, hey, we think we might have a problem. Get us involved early, let us look into it, let us check the application, and see if we can't get you squared away, because usually it is something to be concerned with the installation. The biggest single thing that I want to see whenever I go look at a drive is I want to see 2 green wires in that drive. I want to see one of them from the motor back to the drive. Now you'll notice there's no ground stud, there's no ground bus. I want to see a piece of copper from this motor back to this drive. Not the building steel. There can be a strap from the motor to the building steel, but I want a good copper conductor coming back there. I don't want it hitting a grounding terminal block. I don't want it hitting a ground stud. I want it coming directly back to the drive. I then want a second ground coming from the drive to the system bus, system ground. Okay, very important. And all our installation instructions and everything, our prints, our schematics, everything all indicate that you need to do this. The reason you want to do this is, everybody heard of electrical noise? Let's call it static for lack of a better term. These drives, or VFDs, or whatever you want to call them, AFDs, whatever moniker you want to put on them, okay, send a fair amount of noise out to this motor. Electricity likes to take the path of least resistance. Electricity always wants to get back to the source. So if I'm sending a lot of noise out here, I want to give it a low impedance path back to where it came. So it goes out here through the motor, we get it back to the drive. If we take this same copper conductor and we tie it over here, we've given it a path, but now it needs to go through the building steel, and it might go anywhere. Okay? Well, it might go someplace you don't want it to go, like onto your network, like on your analog signals, like anywhere, like on your control power transformer. In other words, if we don't give it a low impedance path, low resistance path, it might go anywhere, and where it goes might be bad. Okay? So one of the first things I'll look at every single time that I get called in to look at a drive, first thing I do is open the door, and I look for 2 green wires on the PE terminals. If I don't see 2 wires, I'm going to basically tell you I need to see 2 wires. So using the conduit as a ground, unacceptable. Unacceptable, okay? So just keep that in mind. we always want to make sure we keep that ground. The other thing is, the transformer that feeds the drive. In most distribution systems, it's a Y configuration. I'm assuming that this system is also a Y. Anybody know?
I think it is.
I'm about 99% sure that it is a Y. If it's a Y, no problem. If it's a delta, there's some jumpers in the drive need to be removed. Okay? So that's something, your commissioning engineer, your Rockwell guy that's doing the startup, should be asking this question, should be checking, and if necessary, removing the jumpers. The other reason you need to know this is if a drive should fail and you need to replace it, if the jumpers are removed, you need to remove them on the replacement drive. Okay? The jumpers are in various locations, and depending on the size of the drive, may be located, it's in the user manual for each of the drives where these jumpers are located. There's typically two. There may be some of them that just grab a pair of needle nose, pull them off. Some of them you actually have to cut. And again, it varies with the size of the drive as to where they're located and whatnot. But if it's a Y, you don't have to worry about it. Those jumpers stay in, no concerns. The other thing on most of these drives, you will see a line reactor. Okay? That was per the spec. Personally, I think every drive on the planet should have one. Okay? Those are a passive component, however, they are there to prevent the drive from being damaged. They're actually there for a couple reasons. And when we go down and look at the drives, I will point it out what it looks like, so you'll know what a line reactor is and kind of why it's there. All right? The line reactor is there for a couple reasons. First of all, it minimizes harmonics back onto the distribution system. But more importantly, it's there as a protective device ahead of the drive. It'll help protect the drive from voltage changes, spikes, and things of that nature. Okay? It opposes changes in current. It's a current limiting device. So although it's nothing more than some coils, you will see them in every cabinet, and they are there really to protect the drive. Okay? All right. So from an installation perspective, those are the key things that you need to be aware of. Because if you have issues, those are the first questions I'm going to ask. Okay? Do you have a ground from the motor? Do you have a line reactor? Are the jumpers installed? I guarantee you that those are always the first questions I'm going to ask. Okay? We should talk about safety around these things. I know some of you will never, ever, ever open the cabinet. Some of you will. Okay? If you're not qualified, you shouldn't be opening the cabinet, period. Okay? But if you are qualified and you do have to open the cabinet, be aware that just because you've thrown the disconnect, that drive is still alive for a period of time. Okay? There's a capacitor bank in that drive that stores energy. So when you throw that disconnect into the off position and put your locks and whatnot on, you still need to make sure that the display has gone black. Okay? The display is powered by an internally generated 5 volts. When that goes down, the drive is safe to work on. When in doubt, put a meter over the DC plus and minus terminals and make sure it's at a non-lethal level. Okay? So be very, very careful when working on these drives. Those capacitors store a lot of energy. On a 480 volt system, we're looking at 650 volts DC. It'll kill you. So be very, very careful. Again, if not qualified, don't open a cabinet, call an electrician. they know what to do. Special tools required. If you want to work on these, you need to be using, if you want to get accurate voltage and current readings, you need to be using true RMS meters. Okay? If you take your standard fluke meter and try to get a voltage reading off the output of the drive, it's not going to happen. Okay? It's going to read off scale. Okay? So if you are doing troubleshooting, although you really, in most cases, don't need a meter to troubleshoot these drives. The drive has all internal measuring equipment. Basically, if you wanna read anything, you go right to the display. It's extremely accurate, so you really don't have to have a meter. Now again, all those meters that the drive contains is assuming that you have power. You don't have power, you have no display, you have no meter, okay? If you lose power, well, your old trusty digital multimeter is more than adequate for testing the semiconductors and the power structure, testing for shorts, open circuits, whatever. Your standard meter is absolutely fine for that. But if you want to read anything on the output side of that drive, you are going to need, a true RMS meter, okay? Which means, let's say the more expensive type test equipment. Same thing with your DC, if your clamp-on ammeter, okay? If you want to get a secondary measurement of current, okay, in the motor leads, you will need a true RMS clamp, okay? An analog clamp will actually work halfway decent, but it'll only work at 60 cycles. It'll give you a reading, but it'll only be accurate at 60 cycles. The reason being that the device that's used to measure the current in the analog ones is a current transformer, which is only accurate at 60 cycles. Okay? Any questions on installation and concerns and things you've seen, why you've seen them, things that didn't make sense to you? No? Okay. We're going to go to the binder now, and let's just kind of review a typical VFD. I don't have these electronically, so I'm not going to put them up on that one. Sit down, by the way. All right. Go to the tab in your binder, called Equipment Descriptions. And open up your first page. Should be BFP polymer feed pumps. Basically, this is just a typical, the first page is a typical power distribution one line. Alright, circuit breaker as your main disconnect, okay. Branch fusing, and then you'll see the line reactor, the square box with the 3 squiggly lines in it, for lack of a better term. I'm using some very high-tech terms here. Everybody got that? Squiggly lines? Okay, that's that line reactor I spoke of. Again, it's on the line side of the drive. It's there